So it's thank you, Anthony, for organising this. Thank you for inviting me. Thank you, everyone, for turning up. This obviously, well, maybe you're used to early mornings, but I mean, maybe not so much for myself. The title of my presentation is quite appropriate. We're in the middle of the latest Conference of Parties meeting, COP30. The ultimate aim of the COP meeting, certainly since the Paris Agreement, which was COP21, was to keep the world's temperatures below 1.5 degrees C. It's the basis of the Paris Agreement. That's what people have flown sometimes 28 hours to get to Brazil. And that's what they're trying to find agreements to maintain. So I thought it was quite appropriate if I talk to you about what this actually means in terms of lives and livelihoods on planet Earth. If you go above a 1.5 degrees C threshold, you set in motion the crossing of planetary boundaries. And there are 9 planetary boundaries on planet Earth. Crossing any one of those planetary boundaries and staying above it means that you don't have breakfast because there's no food, there's no water, there's nowhere to live. You cross a planetary boundary, the estimate of the carrying capacity of planet Earth is approximately 1 billion people. There are 8 billion people on planet Earth. There are, 32 people in the audience here today? You cross a planetary boundary, only 4 of you are reaching life expectancy. The rest aren't, and it's not going to be pleasant for you. They're the scientific realities of climate, scientific realities. We can all wish something different. We can all believe something different. It doesn't matter. Science follows the laws of physics. You go above 1.5 degrees C, you set in motion, passing planetary boundaries. There are 9 of them on planet Earth. Any one of them will influence your life. And I'm going to talk about 2 today, okay? So that was a nice, positive start. You know, when I give these, I don't know, I wake up in the morning, I'm in quite a good mood, and then I go, I've got to give another talk on this topic. Oh, and, you know, I was at a meeting recently where it's a really interesting meeting. It involved, it was sponsored by Aon, and they brought in sort of thinkers, and I was brought in on climate, and they had someone who was a psychologist and was talking about climate anxiety. And I wrote an anonymous question. I said, well, what about the mental health of a climate scientist? Does anyone consider that? Because I have a phrase that if you knew what I know, you'd be absolutely petrified about what's going to happen. So you've got that sort of anxiety about everyone you care about, your kids, your friends, your families, new and old colleagues. And then on the other side of things, you get the pushback. And, you know, most recently, you get the pushback from Donald Trump, who the morning after Regatta smashed into Hong Kong, says that it's a con job, and says that I'm a con artist. And that's really, really, really hard to hear. You may think, but when you're told that then that I lie, and so everything I'm talking about today is just a complete lie. Every day of my academic career has just been a lie. I lie to people every single day of my life, and that's a really hard thing to have a sizable proportion of the global population think of you. Just think about that. If you had a sizable proportion of the world thinking that you were a liar, and all you've been trying to do is put information out there to try and save people's lives. So, to begin with, what I thought is that I could show my life in terms of climate. So this particular graph is my life. And so you've got, I was born in 1971, and here's 2025. you've got the amount of carbon dioxide on the right-hand side, and you've got the global average mean temperatures on the left-hand side. So when I was born in Manchester in 1971, the global mean temperatures were pretty flat at that time. The amount of carbon dioxide in the atmosphere was around 300 parts per million by volume. And I was born in 71, and in 72 was the first United Nations Commission on climate change. First time they brought scientific leaders together because they were incredibly worried about the observations that were coming out of CO2 increasing, and they understood the laws of physics that carbon dioxide is a greenhouse gas which causes increases in global warming. In the 1970s, in 1975, that was a time period where and this is used by climate skeptics, that there was global cooling. And if you actually have a look in the scientific literature, only about one in 10 papers on the future of climate actually talked about, well, maybe it's going to get colder. 9 out of 10 talked about a warming. I went through into the 1980s as a teenager into high school. My mum and dad didn't worry about my life and livelihood being influenced by climate change, but I certainly worry about my son, who's 13 years old. I significantly worry about what will happen to him in the next 10 and 15 years because of the pollutants that's going into the atmosphere. In 1988, the IPCC was established. In 1992, I went to university, and in university, I took a course on environmental change, and the prescribed reading was the first Intergovernmental Panel on climate change. So I read that report as a 21-year-old in class, and I was fascinated by it because it was a group of scientists that had predictions of what would happen to planet Earth if you increase carbon dioxide, that the temperatures would go up, and that means we would have more rainfall. Those rainfalls would be catastrophic in terms of landslides. The heating would cause droughts and wildfires, and our ice sheets would melt and sea level went up. And I was fascinated that I thought that if I dedicated my life to that, to better understanding a certain phenomenon, then we would be able to solve the problem. So I decided to say that that's what I'm going to do for my life. I read that report and I said, right, I want to go to do a PhD. So I went off to Durham University. I worked in what was called the Sea Level Research Unit, funded by the UK government to look at sea level rise around the United Kingdom. And I got my PhD in 1999. In between that time period was the first COP meeting in Berlin. So at the COP meeting in Berlin, the amount of carbon dioxide in the atmosphere is about 360 parts per million by volume, and the temperature at that time is about half a degree above pre-industrial values. I finished my PhD, followed by some of my work in my PhD, entered into the third IPCC appointment. And at that time, maybe a bit different now, but at that time, if you were a young scientist, what you really dreamed of was going to the United States, because the United States was the premier place where they invested more money in science. They made the discoveries. There were these colossal institutions, the National Ocean Atmospheric Administration, NASA, NSF, NIH. And I dreamed of moving over to the US. And in 2004, I was fortunate enough to do that. I went to the University of Pennsylvania. When I arrived in UPenn, it was at exactly the same time as Al Gore released the documentary film called The Inconvenient Truth. And that was a big game changer for our community, because as a young scientist, I had a decision to make then. Do I retreat back inside, actually, because I was at an Ivy League, back inside my ivory tower and just do academic research? Or do I use the opportunity to try and communicate the science, despite having no training? And I think that's one of the limitations, one of the problems. Hindsight's 2020, but if you look back, one of the problems when the first IPCC was formed, it was just a group of people looking into the mirror, rather than having stakeholders communication experts, lawyers, businesses and governments, and we still can't really get over that divide. But I decided to get involved in climate communication and started at that point to start attending the COP meetings. In 2013, I was rapidly promoted from an assistant all the way to a full professor. The reason for that was because of my work that went into the COP21 meeting, the Paris Agreement. I was part of a group of scientists who looked at the stability of Greenland and Antarctica, looked at basically, you know that if you increase atmospheric temperatures, ice sheets will melt, but they're not going to melt in a gradual pattern. They're going to slowly melt, and then there's going to be a step change to a new equilibrium where they collapse. And so we wanted to know what that threshold is. And so we wrote a landmark paper it came out in about 2015 that said West Antarctica about 1.5 degrees C, East Antarctica we don't know, Greenland ice sheet is about 1.7 to 2 degrees C. You go above that and they collapse. So that went into the Paris Agreement. We then wrote a special report on the IPCC in 2018. I moved over to Singapore, became director of the Earth Observatory of Singapore. So that was a governmental think tank. I had about 170 employees, and we were basically looking at the national security of Singapore and Southeast Asia for climate and geohazard threats, earthquakes, volcanoes, tropical cyclones, heavy rainfall, monsoon variability, droughts, and sea level rise. In 2023, I became the review editor of the IPCC's 6th assessment report. So in the course of this, my academic career has been phenomenal. If I thought that in 1992 in an undergraduate class where I did that as prescribed reading, if someone had told me, well, if you get into climate, you fast forward yourself to 2023, you will be the review editor, I would have thought, well, that just wouldn't be possible. How can I do that? And I managed that trip. And then in 2025, about 6 months ago, I moved over to become the Dean of the School of Energy and Environment. So academically, really successful, lots of grants, lots of papers, lots of students, accolades. But in my impact on actual changing climate is an absolute colossal failure, like a colossal failure. From 1992, the amount of carbon dioxide in our atmosphere went from about 340 to these record levels of 425. We now have temperatures that are somewhere between 1.5, 1.6 degrees C above the baseline. There's a bit of a problem with how this graphic's come out, but this is supposed to have a map of Asia, which you can see a little bit in the background. Now, when you go above 1.5 degrees C, it has a variety of impacts. And this is a slide that I update on a weekly basis just for Asia, just the impacts. The number of typhoons is absolutely staggering. We had a super typhoon hit the Philippines in mid-November. If you, for your students, if they open up an oceanographic book, okay, they talk about the hurricane or the typhoon season. It's supposed to end on the 1st of October. While we were below that threshold, you didn't get events after October. As soon as you go above those events, the world is unstable and you get black rain events, unprecedented in Hong Kong. You get 2 T10s within the space of 6 weeks in Hong Kong. Philippines is hit back to back by super typhoons. Hurricane Melissa in Jamaica recorded wind speeds, they're unconfirmed, but recorded wind speeds of 404 kilometers per hour. Again, the scientific community did not think that was possible because we didn't think we'd be stupid enough to go above the 1.5 degrees C threshold. So I'm hoping these animations show. but they don't. Oh, that's very disappointing. We can click on that. We'll just move those two by. So I had two animations to show you about how temperature has evolved through time and how that relates to carbon dioxide. But I can show you this graph as a substitute. So this graphic here is basically my work, sort of my contribution to science. So these are the carbon dioxide values. So you observe carbon dioxide. The values have been observed since the 1950s from a station in Hawaii, a station that Donald Trump is shutting down on January the 1st, just because he can. And so we have records that are taken every single, we will do until January the 1st, that are taken every single day, which, because of the location, record carbon dioxide for the planet. You can then match them together with carbon dioxide records from ice cores in Antarctica. So I've been to Antarctica quite a few times, and in Antarctica, when it snows, it lays down on the surface as ice, and that ice builds up over time. You can take a drill core through the ice, and then it's layered for each individual snowfall season, and contained within it are ice bubbles. And within those bubbles is the atmospheric gas content of when the snow was laid down. So you can do this, and you can go back thousands of years. The previous animation showed carbon dioxide values going back 800,000 years. The amount of carbon dioxide that we have in our atmosphere has not been seen on planet Earth for 800,000 years. Indeed, we think the last time that it has possibly been on planet Earth was 2.8 million years ago in a geological era known as the Pliocene. 2.8 million years ago, the temperatures of planet Earth, because of the carbon dioxide, were 5 degrees C above warming. That's a scientific fact. The sea levels, because temperatures were 5 degrees C above warming, Greenland collapsed, West Antarctica collapsed, and sea levels were 20 meters higher than today. That's a scientific fact. Temperatures. So you can observe temperatures, all the temperatures from the upper atmosphere, the lower atmosphere, urbanized areas, non-urbanized areas, average it together, you get your averaged temperatures. You then can couple it together with a geological proxy. In this case, we use bristlecone pine tree rings. The tree rings, wider tree rings correspond to a warmer temperature, narrower tree rings correspond to a narrower temperature. This is what is known as Michael-Mann's hockey stick graph. And it shows again that temperatures rapidly rose in the 20th century in corresponding to the CO2, and then have been remarkably flat, just like the CO2. And the temperatures on planet Earth today are warmer than at any time in the last 127,000 years. That's a scientific fact. 127,000 years ago, the Earth has an elliptical orbit around the sun, and we had slightly more solar radiation. That was the driver for the previous warm period. This is carbon dioxide. So when I was starting my PhD, we knew about this. Michael-Mann was working on this, and I wanted to do this. So what I thought is, right, I want to see what the relationship is between carbon dioxide, temperature, and sea level. And I started in my PhD, and it was completed a couple of years ago by one of my last graduate students, Jennifer Walker. And again, you show that the rate of sea level rise is really, really fast in the 20th century, and then it's stable for the previous 2,000 years. The amount that our sea level rise in Victoria Harbour right now is the highest it has been for 120,000 years. That's a scientific fact. Okay, so we've got all these facts. The science is so unbelievably clear about the relationship. As soon as the Industrial Revolution took off, you put CO2 in the atmosphere. Carbon dioxide is a greenhouse gas. It traps in long-wave radiation emitted from the Earth, raising global temperatures, and in my field, raising the sea levels. So these tipping points. So, scientific community spend a lot of time running their models, validating their models, and seeing how different levels of CO2 will change temperature, will change sea levels. But we're also aware, if you look through the geological record, that the rate of warming and cooling for natural variability in climate is not smooth. And we know that the Earth has these 9 planetary boundaries for which civilization depends upon. And these are them. So them, the most prominent proponent of this is Johan Rockström. World Economic Forum. He will be in COP30. Stockholm Resilience Centre is really the centre for understanding this. And then we've contributed this, both understanding the Greenland and the Antarctic ice sheet, and then also understanding the fate of our ecosystems along the coastlines, mangroves, salt marshes, and coral reefs. Each one of these are large scale. Each one of these are interconnected. So if one goes, there's a cascading effect to the other going. All of them are irreversible. That's the problem with climate change, is that there isn't an antidote once you go over these thresholds. There's not a vaccine, unfortunately. We can't just say, oh, well, I'm really sorry, Ben, you were right, and I really don't want my kids to die. So can we do something about it? And I would say to you, no, I'm really sorry. Your kids are going to die. They're really going to suffer. And that's because these are huge systems. Antarctica, just as an example, has enough water within it to raise global sea levels by 60 meters. The Amazon rainforest provides our oxygen on planet Earth. Coral reefs, tipping point, 99% disappear. Permafrost, that holds together all the natural methane on our planet. You melt the permafrost, you produce more methane in an individual year than we've ever produced since the beginning of the Industrial Revolution. Arctic sea ice acts as a mirror on our planet, keeping us cool. But what I want to talk to you initially about, and I really hope the animation shows, is what happens with the Atlantic circulation. And it's interesting I'm giving you this presentation today because, and I've talked about this to a variety of people, that these 9 planetary boundaries are a national emergency. They should be addressed by the Security Council. They're too big to be addressed by an insurance company, a big bank. And today, the Icelandic government identified Atlantic circulation as a national security threat, and it's being talked by their Security Council. And unfortunately, I don't know why when we transferred it over, but the animations are not working. So I'm not going to give an impression of an animation. But this was an animation of the ocean circulation current. I'll try and, without the animation, I can just use the map. Okay, so the Atlantic circulation, warm water forms in the Gulf of Mexico. It's very warm and it's salty, and it migrates around the tip of Florida, goes past North Carolina, and ends up in northwestern Europe. When it ends up in northwestern Europe, it's lost its heat, but it hasn't lost any of its salinity. So it becomes incredibly dense. Okay, so when it's dense, it sinks. It's the most dense water on our planet, and it sinks because it's cold, like the surrounding water in the Arctic, but it's very, very salty, so it sinks. And it sinks to the base of the North Atlantic and then slowly moves all the way to Antarctica. It circumnavigates Antarctica, it upwells, providing the biodiversity in the Southern Ocean, sinks again, pops up again in the Pacific, goes through the Indonesian through-flow, pops up in the Indian Ocean, goes around the Cape of Good Hope, and then ends up back. It's called the ocean circulation. The amount of water in the Atlantic on this current is greater than all of the rivers in the world combined. It's a colossal body of water. It transports around a third of the excess heat in the tropics to the poles. It's the reason why we have a habitable climate in the tropics. It doesn't get too hot. And it's a reason why you get a habitable climate in the mid to high latitudes, because it doesn't get too cold. In areas of Scandinavia, it provides over 50% of the heat. More heat than they get from solar radiation is from this current. As I said, this current is influenced by salinity, okay? So if you change the salinity, the current stops. So you have to say, well, how would you change the salinity? Well, you'd have to have a huge body of fresh water on our planet. The huge body of fresh water on our planet is the Greenland ice sheet. So when the Greenland ice sheet melts, icebergs commonly come out of the western parts, an area known as Jakobshavn, comes out into the Atlantic. You know, the Titanic is an example of it. One single iceberg coming out here and the boat going towards Newfoundland being hit by that. But huge volumes of ice, gigatons of ice are being melted by Greenland. It changes the salinity. It shuts down this current. This current, last time it shut down was 12,900 years. So I had a nice animation to show you this. But these are the implications of it, okay? So the big problem for us now is because we've crossed that threshold and we're doing nothing about carbon dioxide, 70% of our models are now predicting collapse within decades. This collapse, the median age is 2050. Okay, so we're not talking about something where it's your grandchildren or your grandchildren's grandchildren. You're talking about 2050, 25 years' time, this stops. This stops the impacts. I delivered this message to the King of Sweden about this time last year. And so trying to influence people who I think could make change. So we delivered this message to the King of Sweden because temperatures in Europe, because you're stopping the warm water, means that in northwestern Europe, they rapidly freeze. The Day After Tomorrow is the feature film about it, if any of you have ever watched that. But European temperatures drop 15 degrees C. So for Stockholm's summertime temperatures around 14, 15 degrees C. When you close AMOC, they never get above freezing, and their wintertime temperatures are minus 25. The whole agricultural sector collapses. Fisheries, the whole of the fisheries in the Baltic and the North Sea collapse. Trade routes, it's frozen over, collapse. It causes these knock-on effects. The oceans absorb about 30 to 40% of our carbon dioxide. So every time you switch on your car or switch on your light or use your air conditioning, our oceans are absorbing around 40%, our tropical ecosystems around 30%. So around 40%, as soon as AMOC weakens, it cannot store any more carbon dioxide, therefore accelerating climate warming. It will cause extreme weather. So instead of having Typhoon Regasa happening twice within 6 weeks, it will happen every week of every year in Hong Kong. Sea level rise should just accelerate one area hotspot, and the Amazon rainforest collapses. Because what happens when you slow down AMOC is what's called the intertropical convergence zone, where all the weather of the tropics migrates southwards, and therefore Amazon, huge decrease in rainfall, becomes a savanna, carbon is released, and climate warming is going up. This is the severity of it, folks. 25 years. 25 years. And we're not going to... So that's one, okay? The second one I'm going to talk about is Antarctica very briefly. Again, this was an animation, well, it was a video, because I've been to Antarctica a lot of times, and I struggle to ever describe what Antarctica's like. And And so I have this drone footage of when we were there in 2023. And this is our research vessel. It's a former Yugoslav frigate. Also has berths of about 120, 140 people. And it's just minute against the background of Antarctica. And Antarctica is, it's not very, I went in the 90s and it never looked like this. It was all very, very, perhaps the most famous of all the glaciers, because the Doomsday Glacier, if it collapses, and the British Antarctica Survey say it is collapsing right now, if it collapses, it will cause a sea level rise of some 2 to 3 meters, which would inundate all of Victoria Harbour. So we worked on sea level rise, and this is just to show you how rapidly things are changing. So this was the previous estimate when we were below 1.5 degrees C of what sea level would do under a low emission or a high emission scenario. So on a high emission scenario, under the previous estimate, it was less than 1 meter. Now we're above the 1.5 degrees C. It's now 2 meters. You're doubling the threat, which doubles the exposure of people that are impacted. We did this for all cities around the world. The bigger the shade of red, because it's going to be spatially variable, the greater the rate of rise. There are regional factors. A lot of cities in Asia are bigger than this. One of my big arguments since I've come into Hong Kong is with the Hong Kong Observatory, because they use the previous experts. I've been trying to say to them, well, no, now you're above 1.5 degrees C. Those previous estimates are out of date. So the Hong Kong Observatory, in trying to keep you all safe from sea level rise, predicts sea level will hit 2,100. It will be just under 1 meter. We've got over 2 meters now. So we're trying to work with the government to try and improve its regulation regarding sea level rise. So what can you do in response to this? I mean, what can society do? So when I came into Hong Kong, one of the things that the government asked me to do was to put together a simple manifesto that the government could try and think about doing. So the first thing is to invest in the science of these tipping points for early detection and monitoring. So we have the models that suggest that AMOC will collapse by 2050, or certainly 70% of them in the next few decades. So we need to provide the data to indicate that collapse is happening. So we need to develop the methodology for detection, and then we need to monitor it. And that's something that we're going to be doing in my new school. Then avoidance is obviously key. You do not want these things to happen. Hopefully I've sort of indicated you to that. And we have the solutions, but we just don't have the behavioral change. We have the solutions in renewable energy. Solar energy is the cheapest form of energy we have ever had. It's cheaper than coal has ever been, or oil or natural gas. There are obviously bottlenecks associated with improving the grid, bottlenecks in terms of transforming this technology to developing nations, but we certainly have the solutions. What we try and talk about to do with climate change is that climate change is a real problem, but climate solutions, one of our real issues in communication, has we've not been able to get over to people that these are no regret strategies. Every solution on climate is a positive for you. We all know, or we all sort of understand, that green tech and the green agenda is the economic growth of the 21st century. It is not petroleum. We all know that if we improve our environment, it will improve our health. It will stop pandemics. If we change our diet, it improves our health. If we invest in transport systems, it will improve our health. We all know with climate change that it'll improve our finances. I mean, I'm sure any of you who drive a EV or have solar cells, you know that you can reduce your energy. I'm part of the sustainability task force for City U, and we've just done this huge endeavour over the last 5 years of putting in solar cells. What happened to it? We had a 40% reduction in energy costs, which then we can go and invest in the science. Insurance companies and governments need to simulate what happens. That is something that isn't done right now. We do these gradual estimates. And so with these new sea level rise estimates, I want the government to have a look at how expensive it's going to be to armour Hong Kong. The airport goes under the water, a lot of Victoria Bay. It's going to be a huge financial investment, but we have to model these because, again, that may give the incentive to avoidance. And then if we move on to the latter ones, I mean, the other thing that we have to be aware of is that climate change is here now. You can't stop it. The climate that we have in 2025 will only be worse in 2026. And it will be worse for decades now. Every single year it will be worse because carbon dioxide as a gas stayed in the atmosphere for hundreds to thousands of years. And so until we develop technologies that can adequately remove CO2 from the atmosphere, we're not going to change those concentrations. And then their impacts on the oceans take hundreds of years to get back to equilibrium, and the impacts on the ice sheets take thousands of years. So we're going to have to adapt. So again, one of the huge problems with communication is because people say, oh, well, this is the new normal. No, it's not, because next year is going to be different. So we don't exactly know what next year will be. It depends upon natural variability impacting climate change. But, when I came into Hong Kong in April, and I knew it was part of this natural variability of El Nino, known as La Nina, I could have told everybody you'd have record-breaking rain. I mean, climate change is very, very complex, but some general things are incredibly simple. So when El Nino's in the El Nino phase, you get a heat wave. When El Nino's in the La Nina phase, you'll get record-breaking winds. And you just have to look at the projections. They commonly come out of NOAA. Whether whether Trump will allow that, I don't really know. But anyhow, we definitely need to adapt. And we need to think about those adaptations being done in a sustainable way. Communicate. I mean, this is one of our problems, is how do you communicate these risks without fatalism, without all of you leaving this room going like, well, we're screwed here. Well, I may as well just enjoy my life and, go and find a bunker in the middle of somewhere and try and live it out with your family. So we've got to try and get away from that. The problem is in 5 years' time, if nothing has changed, I would have refused this talk. I refuse all talks because we're done. Yeah, you've got about 5 years for us to accelerate in renewables, invest in the science, and have behavioural change. Then we can solve this problem. There is no reason why we can't have a sustainable life if innovation and technology can outpace climate change. Currently, it isn't. A big problem right now is that these events are transboundary. The great thing about COP is that all countries in the world are there, except Russia and except the United States. And supposedly COP is going quite well this year because you don't have the wrecking balls of the United States trying to derail everything. Because there was a summit about a month ago about maritime trade, where it was about trying to decarbonize maritime trade. And the Trump administration came in and said, well, if you sign up to this agreement, we're going to put taxes on anything that comes into our ports. So we've got a real problem to do with international agreements, because instead of having apathy from a Trump administration, you've got direct aggression against climate change. So this is something that hopefully the world will come back to thinking about agreements and thinking about that we're all one people. And then obviously something that I've been trying to do here in Hong Kong is to try and get finance to basically think about the technology pathways. Few more minutes. Yep, I've got 2 slides. Okay, so the first thing I'm just going to is, and I wasn't going to leave without putting an advert up for us. Okay, just to tell you why I came in to Hong Kong. Well, the first thing is to develop a centre in climate science. Hong Kong doesn't have one. It has, world-class universities that you send your school kids to, and they, in medicine and in business and in law and engineering and in science. There are some elements through engineering in resilience, but there are no climate science centres. So there isn't a group of students in Hong Kong actually being told how the Earth works. And so I always think, well, if you don't know how the Earth works, how can you then make informed decisions, whether you are in medicine or in law or in business? How can you make an informed decision as an engineer on what you must protect for if you haven't got a science background in climate? So we're setting this up, and my job at the moment has been interviewing people to come over to Hong Kong. One of the very sort of small silver linings of the Trump administration is that lots of people want to get out of the United States. And so I wrote an article in the South China Morning Post that I said of our long list, for our positions, we had hundreds of applications, but of our long list, so of the 20 people that we Zoomed, 15 of them were either got their PhD from a US institution or were currently employed in the US. So we're hopefully going to hire 5 assistant professors that will start this time next year. And that, together with myself and someone I brought with us, means we'll have seven assistant professors looking at climate science. And then we'll try and develop undergraduate programs. We'll try and work policy. Each assistant professor commonly has a team of 10 people. So from 0, we could have this group of around 70 people, which is it would have a huge impact on understanding climate science, trying to communicate it, developing policy, working with engineers to try and solve this problem. And then finally, and obviously what I'd like you to all do is take your phone out and take a photo of this, is that, we already have some quite amazing programs at our school. So the School of Energy and Environment is the only school in Hong Kong that is interdisciplinary between environmental problems and engineering solutions. We're a small school. We only admit 50 or 60 students per year. Each one of those students is guaranteed an internship. Each one of those students works within a research lab. And we have a variety of international programs. Our big one at the moment is with London School of Economics on our double degree program with sustainable business. We work with Columbia on our economic and finance, and then we work with Cambridge on our flagship program. So the students have the ability of 3 years at City U and then 1 year at Cambridge. So these are our 4 programs. I know parents are interested in this. Our graduating class of last summer, 96% got employment, average salary of around 23,000 Hong Kong dollars per month, which was second highest within City U. So we're a successful program already, but I want us to do climate as well. Okay, all right. I apologize that the animations didn't come through, but hopefully I was able to explain the urgency of climate change. But we still have time. You're very fortunate. You're the most fortunate generation because you know the problem and we have the solutions. It's not like the start of the pandemic where we knew the problem to a degree and we had no solutions. We know the problem. We know how bad it can be. We have the solutions and we can make the world a better place. But time is running out. 5 years to enact, to slow down the rate of carbon dioxide. So when I mean act, in 5 years, you have to limit the amount, you have to peak your carbon dioxide emissions. Every single country has to peak their emissions. One really good piece of good news was this week, China peaked its emissions. So they peaked their emissions. They are ahead of the curve. And so that was a great lift for us, that they're ahead of the curve. We need other countries to follow China's lead. Okay, thank you very much.